Hi, Algebra 2. This is Unit 6, Lesson 10, and today we're going to talk about equations of circles, which is something that you did back in geometry, so it should be pretty easy, nice review. So first, I just want to make sure you all remember that distance formula. So the distance formula, if I have 2 points, x1, y, and y, x1, y1, and x2, y2, my distance is the square root of x2 minus x1 squared plus y2 minus y1 squared. All right, so let's look at exercise 1. I have a circle. A circle is a collection of all points that are a set distance, which is actually the radius, away from a point, its center. The circle shown below has a radius of 5 and a center of 4, 2. All right, so this radius right here is 5. This says 4, 2. It's kind of hard to read. And this one up here just says xy. I don't know why that got cut off a little bit. An arbitrary point, xy, is marked. Using the distance formula, show that the point 7, negative 2 must lie on the circle. Verify it graphically. All right, so I'm going to take the center of the circle, which is 4, 2. I'm going to take this point, which is 7, negative 2, and I'm going to use my distance formula to make sure that it has a radius of 5. If it has a radius of 5, then that point lies on the circle. All right, so I'm going to do 7 minus 4. I'm subtracting the x's squared. And then I'm going to subtract the y's, negative 2 minus 2. So this is going to be 3 squared. And this is going to be negative 4. I know it's a negative, but you're squaring it. 3 squared is 9. Negative 4 squared is 16. And the square root of 25 equals 5. So yes, it does lie on the circle. Let's look at the point 7, 2. So 1, 2, 3, 4, 5, 6, 7, negative 2. And there it is, 7, negative 2. They wanted me to verify graphically that it was on there. All right, so letting x2, y2 equal xy and x1, y1 equal 4, 2, let's write the distance formula for all points on this circle. All right, so my distance is just going to be, I'm subtracting the x's, x minus 4 squared, and then I'm subtracting the y's, y minus 2 squared equals 5, because any point should have a radius of 5. Now they want us to square both sides of the equation that I just did, so this equation right here, they want me to square both sides. When I do that, the radical on the left disappears, and on the right, 5 is just going to be squared. And 5 squared is 25. This is the equation of a circle, which we went over last year. All right. Show algebraically that the point 1, negative 2 must lie in this circle. So I'm just going to plug in 1 for x and negative 2 for y. So it's going to be 1 minus 4 squared plus negative 2 minus 2 squared equals 25. So this is negative 3 squared plus negative 4 squared equals 25. And 9 plus 16 is 25. That is true. So that point does lie on the circle. All right, so the equation of a circle is x minus h squared plus y minus k squared equals r squared. The center of my circle is hk. The radius of my circle is r, and xy is any point on the circle. So remember that it's x minus h squared and y minus k squared, but yet my center is positive h, positive k, so I'm always doing the opposite signs of what's there. All right, so let's look at some problems. Which of the following equations would have a center of negative 3, 6, and a radius of 3? All right, so right away, the number on the right is the radius squared, so I'm going to get rid of those because 3 squared is 9. Now, h and k have the opposite signs that are there. All right, so it's going to be x plus 3 squared and y minus 6 squared equals 3 squared, which is 9. So it's choice 2. This is just a review of circles from last year. All right, so let's practice a bunch. Each of the following equations determine the circle's center and its radius. If the radius is not an integer, express it as a decimal. All right, so again, it's x. Oops, my pen isn't. There we go. X minus h squared plus y minus k squared equals r squared. And hk is the center. So right here, my center is going to be +2, +7. This is 100 is r squared, so my radius, I have to take the square root of that number. My radius is 10. All right, look at B. Again, the center, just do the opposite signs. +5, -8. The number on the right is the radius squared, so to find the radius, I take the square root, and the square root of 4 is 2. If there are no numbers, then my center is just 0, 0. The number on the right, 121, is the radius squared, so the square root of that is 11. D, my center is -1, -2, and my radius is the square root of 1, which is just 1. On E, one of them has a number and one doesn't. So the center is going to be 0, 3, and my radius is the square root of 49, which is 7. And on F, my center is -6, +5, and my radius is the square root of 18, and they said they wanted us to do this to the nearest tenth. So the square root of 18, do it in your calculator. Nearest tenth is 4.2. Okay, so we'll practice these tomorrow. And if we have extra time tomorrow, we'll go back and do the